Today in this session we will be studying about the determination of PM2.5 in ambient air in accordance with IS 5182 part 24. Particulate matter PM is a mixture of solid particles and liquid droplets suspended in air. Depending upon the aerodynamic diameter, particulate matter is classified as PM10 and PM2.5. When we say PM10, this suffix represents the diameter of suspended particle in micrometer. If we say PM10, so the diameter of suspended particle will be 10 micrometer or less. Or when we say PM2.5, the diameter of the particulate matter will be 2.5 micrometer or less than the 2.5 micrometer. That is how we classify. And this PM2.5 is having a lot of health hazard. We often feel breathing trouble wherever the PM2.5 concentration is more than the good value, means 0 to 50 or 50 to 100. These are good and satisfactory value. If it is more than that concentration of PM2.5 particles or more, then we feel the breathing difficulty. And also there is cardiovascular disease, developed cardiovascular disease, because this PM2.5 enter into the lungs and also mixed with the blood, so it creates the cardiovascular diseases. And often we feel the irritation in eye, throat, nose, etc., wherever the concentration of this particulate matter is more. So we do the monitoring to know the how much concentration of PM2.5 is there in the atmosphere of the field wherever we are intent to make a factory or develop any project. So there we do the monitoring, and we also monitor in the areas of the city wherever we expect that there will be more concentration of PM2.5. So we do air quality assessment, help in understanding ambient air quality trend and patterns. So we find out the air quality index, and based upon that we inform the citizens that this is the concentration, and we also take the corrective measure after knowing the value of AQI or after the assessment of air quality assessment. Environmental impact assessment. Also we determine the air this PM2.5 wherever the we are proposing the project, or road project, highway, railway, or any project where it is likely there will be pollution or there will be emission of a lot of gases. So there we go for the environmental impact assessment, and we also in the assessment itself what should be the corrective measure, etc. is written. Then only the project are cleared. So we do this environmental impact assessment for the clearance of the project, essential for clearance of the project and impact prediction. And wherever we are constructing highway or railway project, in the any construction project, there also we monitor the PM2.5 to know the concentration, so that we can take the corrective measure whenever it is in excess, or we and green cloth, etc. we use, so that the emission of this particulate matter do not affect the society. And whoever is working there, they also use the mask, so that they are not affected with this fine particle, because it is very dangerous for the health. Now for measuring this PM2.5, this is the sampler we use for the determination of PM2.5. It is consisting of inlet. Then first there will be one impactor where we segregate the particle greater than 10 micrometer with the help of tube. This is Vince impactor, means well in 96 Vince impactor. There we again have another filter from 37 mm size. There we segregate particles between 10 micrometer to greater than 2.5 micrometer. Here it is segregated. Then this filter holder, here we have the filter cassette. There we collect with the help of, we draw the air, create the with the air difference section, and then this particles less than 2.5 micrometer gets collected over the filter, and then we measure the difference and the number air, sampled air means for 24 hour, 8 hours, 6 hours, whatever we sample, we divide with the volume of air and find out the concentration of PM2.5 in microgram per cubic meter. So this is one instrument. This is also under here the filter holder is in this shape where this filter cassette can be directly placed, or we have the lens impactor here, well uh, well well impactor 96 win. Here we have the filter of 37 mm size. Here we have the PTFE filter 46.2 mm size, and from there particles greater than means less than 10 micrometer pass through this tube, and here again it is segregated. The particles greater than 2.5 micrometer to 10 micrometer are arrested here, or we can say they get choked here, and after that uh, less than 2.5 micrometer gets deposited in the PTFE filter, and that is measured and PM2.5 is calculated. So principle of the method: ambient air is drawn through the size selective PM2.5 inlet at a constant flow rate. Particles having aerodynamic diameter less than 2.5 micrometer are collected on a conditioned PTFE filter. The PTFE filter is weighed before and after sampling using a microbalance. The increase in filter weight represents the mass of PM2.5 collected. So for knowing the PM2.5 concentration, we take the weight of filter before and after, and W1 minus, we do the W1 minus W2, and say for the 24 hours we have taken. So for every past the air volume 16.67 ideally liter per minute. So we convert by multiplying 24 hour in minutes. So we get how much volume of air passed in 24 hours. We divide with that, then we get the PM2.5 concentration. Now this well impactor, wind impactor, we open. Means this is the sampler. Then we open the wind impactor and we fit with the filter. This filter is 37 mm size. Uh, in the well, we keep the filter. We keep the filter in the well, and with the few drops of the silicon silicon iron, we wet it. Once it is ready, then we place in the win and make it ready. Now this is complete. We have placed the 37 mm size glass fiber glass fiber filter glass fiber filter, and this impactor we made ready. We few drop of the silicon iron with the drop, not just pouring with the drop. 3 to 4 drop is sufficient, so it is wet, and thereafter uh, glass fiber filter is ready for use. So we place in the well impactor and we assemble this well impactor. We place the filter, and this is bottom, this is top. We make it ready. Then we open this filter holder, and filter holder also we open and place that filter filter cassette consisting of PTFE filter of 46.2 mm size in this, and we also make it ready. This is filter for the collection of PM2.5 less than 2.5 micrometer of the particles. So we condition it. This filter we condition for 24 hours by keeping in descator at 25 degrees centigrade plus minus 2 degrees centigrade for 24 hours. Once it is conditioned, then we take the measurement. This is the process of conditioning. Then we take the weight and keep it ready in the cassette, filter cassette. We keep it ready so that it is not disturbed. There it should be ID should be properly marked so that it's not mixed. So we condition the filter, and after conditioning the filter, we make this This filter holder also ready, and place winds inspector means this one, and then filter holder, and the instrument is ready for the test. Now we should ensure that wherever we are placing the instrument, it should have minimum 2 meter height from the floor. It is given the IS code. Means aim is to place to collect the representative sample. It should not be in a hidden place where the representative sample is not able to take. So it should be have the this inlet height from the ground floor wherever we are placing should be minimum 2 meter, so that we can get the representative sample. This should be ensured while working at site. So practical procedure: condition the PTFE filter under controlled temperature and humidity. So control temperature is 25 degrees centigrade plus minus 2 degrees centigrade, and humidity should be RH, relative humidity should be 45%. Record the initial conditioned weight. Then we record the initial conditioned weight as W1. Place the filter carefully inside the filter holder. Inside the filter holder means place this filter inside the filter holder carefully. After taking the weight, record the initial flow rate. Whatever flow rate we are settling, like 60.67 liter per minute. Operate the sample continuously for 24 hours. We should, in the IS code, it is given for 24 hours. So we continuously operate the sampler for the 24 hour. Record the final flow rate. Once when we are stopping the test, we again should take, and we should average. When we started say 16.67, and when we finish it is 16.40, then we take the average flow rate. Remove the filter using forceps. This filter should not be directly handled with the hand. It should be carefully handled with the forceps, and care should be taken should be the plastic, should not be the steel one, so that electrical charges affect the weight. So forceps. Condition the exposed filter. Again we take the filter with the same conditioning, take in the desiccator for 24 hours at 25 degrees centigrade plus minus 2 degrees centigrade and relative humidity 45. And once conditioning is over, record the final conditioned weight W2. Volume of sampled air for 24 hours at the rate of this average of before and after. We multiply and get the volume, and the weight difference between the initial and final weight increased is W2 minus W1 divided by the air. If we have done for 8 hours, 8 into 60 minutes, or if we are taking liter per minute, we have to check the instrument. When it is directly given in the cubic meter, we should take. Nowadays microprocessors are there, they directly give. So whatever is there, the volume has to be taken in the cubic meter. Otherwise, we have to convert into the cubic meter. So this is the conditioning. When we have taken out the filter, we again placed in the desiccator for 24 hours at the rate 25 degrees centigrade plus minus 2 degrees centigrade. Relative humidity should be maintained 45%, and then after 24 hours we take the weight WT accurately. We measure the weight very accurately, means our sensitivity of the this balance should be 1 microgram with the sensitivity, and preferably 1 microgram. We can use also 10 microgram, but it is preferably it should have sensitivity of 1 microgram. So we prepare our this balance and take the weight W2. Once we have measured this weight W2, so we record our all the observation where we have taken. So in this observation, say for example, Panki Kanpur, where the thermal power is there. Sampling time is 24 hours. Initial flow rate recorded is 16.70 liter per minute. Final flow rate 16.40 liter per minute. Average flow rate 16.55 liter per minute. Filter ID, the filter ID, what we say, filter ID is PT260727015. Initial conditioned weight 4.56821 gram. Final conditioned weight 4.569085 gram. So this W2 minus W1 is, when we minus this, we get 0.000875 gram. or we can say it's 75 micrograms. So this the flow rate is 16 point, average flow rate is 16 point, average flow rate will be, because 16.70 plus 16.40 divided by 2, we get 16.5 liter per minute. So we get the average flow rate 16.55 liter per minute. Total run time 24 hours. So 1440 minutes. So volume of air sample is 16.55 into 1440 in cubic meter. It will become 23.832 cubic meter. Calculation for PM2.5 concentration 875 divided by 23.832 cubic meter, so 36.72 microgram per meter cube. So we can compare. This is range in 0 to 50 microgram per meter. So air is in good condition. So with this, how to measure PM2.5 we have completed. Thank you.